Thank you for joining. Right now we are running the SR50 Solvent Recovery System. We literally rolled it off the truck less than an hour ago. We've been running for 45 of those minutes. But we have our feed tank that's mostly ethanol with about 2% oil in it. So this is like pre-extracted biomass, so it's very low concentration. But we have 2% oil in ethanol. We're flowing it through here. This is our computer-controlled valve. The computer knows just how much to open the valve to get the process to run correctly. This is the evaporator. It's only getting to about 60 Celsius in here, but we're under vacuum, and it's a very high surface area evaporator. So we're actually targeting about 5% residual solvent. So this is the oil output. What doesn't evaporate collects at the bottom and flows out here to the oil pump. And then the vapors flow over here to the condenser section. And you can see we're flowing a really good rate of ethanol out. The pump runs on a pulse, so in 1 second, there you go. And if we go to our computer control screen, so this is the main screen that you'd be interfacing with. It's literally start and stop. And you get one setting, which is residual ethanol. We're targeting 5% right now. So that means that the entire system is controlling itself so that it's heating and pulling the right amount of vacuum and flowing the correct amount of material so that once it comes out of that evaporator and collects down here, there's a temperature probe and a vacuum transducer. It knows, it can calculate how much residual solvent is in the oil. So right now we're targeting a really low concentration for a very thick oil, but you might want to have a higher concentration just so that the oil is a little more pourable. Like 15% is a really common target. And we also have a screen down here that shows the distillate output. So we've been doing 60 liters an hour of distillate. You can ignore the residue. That's we had a sensor malfunction that caused it to think it was running a lot faster than it was. It's a heat pump driven distillation system. So it uses about 1/4 of the power of a traditional process, even less if it's comparing to like a rotovap. This is worth about like 5 rotovaps in capacity and uses less power than one. We have like one 30 amp circuit here that's powering the whole thing. There's no external heaters, no external chillers. Everything's handled by the heat pump system that's in this enclosure and computer controlled. This is the evaporator section. So we're feeding from this barrel, which has mostly ethanol with a little bit of oil in it, coming up through the computer controlled valve into the liquid separator where the unevaporated oil flows out and collects here and can get discharged by the oil pump. And then the vapors come over the top here to the condenser where they're condensed and then also pumped out. So we have about 60 liters per hour of ethanol coming out of this pump here. And then we should average about 3 liters an hour of oil coming out of this pump, which it just needs to, there it goes. It needs to be triggered in order to run. And that's the SR50 solvent recovery system. And again, we literally rolled this off the truck about an hour ago and we're running 45 minutes ago. It's literally roll it off, plug it in, press go. And the solvent quality on this is excellent. Like there's not a trace of color. We could walk away. It's self-tuning. So it's always going to target that residual oil concentration that you programmed. And then if the tank runs dry, it can sense that. It'll turn itself off. Really, all you need to do is press start and stop. That is it. Sitting on that, I can trigger it. Here we go. You can see this is the automated screen where it's just again start stop. We have our residual solvent target. We're targeting 5%, which is a pretty good, thick, low percentage. We have our orange line. That's our sorry, our engineer is online. We have our distillate output rate, so it's really steady, just below 60 liters an hour. And our oil's probably not what the oil level says because it's so thick that it's triggering our sensor a lot. But we are expecting, I think, 3 liters per hour out of that based on our feedstock percentage. So our feedstock's coming out of this barrel. So this is like 98% ethanol, 2% oil, just feeding through our automated valve up to the evaporator. Very hard to see into the separator. It's blacked out with oil. But the oil flows out of here into this collection bucket. We have a good thick oil in there. And then the solvent's coming out into this barrel, nice and clear, about 60 liters an hour on average. The pump does run automatically on a sensor, so you're not monitoring this. It's just running on and off all by itself. So yeah, that's the primary vacuum pump. You don't need a big vacuum pump for solvent recovery. In fact, for most solvent recovery systems, you want about the smallest vacuum pump that will effectively pull down your system. There is a big compressor inside. So inside of here is the heat pump system. So most of the energy from the process, like 99% of the energy, coming from the compressor, which is simultaneously the chiller for the condenser and the heater for the evaporator. So that's the magic of the system, which uses only about a quarter of the electricity of a traditional falling film, and even less than a rotobat. The refrigerant is going directly to the tube and shell. So I keep saying that this is the condensing session. It's the ethanol condenser, but it's the refrigerant evaporator. So yeah, you have condensation and evaporation happening on both sides of this guy. And again, this is the process evaporator, but it's also the refrigerant condenser. You have hot gas refrigerant coming in and then warm liquid coming out. So it's direct contact for maximum efficiency. 60 liters an hour is the top of the system. It's rated for 50 liters per hour of ethanol, and it always runs to the maximum that it can while hitting your residual solvent target. So it's fully automatic, and it just hits that residual solvent target, whatever the rate, and then it can run other solvents. So for example, heptane usually runs around 90 liters an hour, much faster. Or if you distill water on it for some reason, it goes down to about 20 because of the different enthalpies of vaporization. And going back to the question of electricity, it's single phase. So we actually have an inverter in the box for the compressor. So you only need single phase power, 30 amps circuit. 200 to 240 volts. So it's like 208 and 240 volt both work. And then like this is the oil output. The coiling down there. It's a pretty low concentration feedstock, so the oil output rate's not super high. But again, the machine runs to a specific residual solvent in the oil. So the oil quality will be consistent regardless of what feedstock you put in, as long as you keep the same setting of like, you have 5% right now. A lot of people run a higher concentration just to keep it a little soupy so it's easier to pour. Yeah, the separator, this is the separator. So it is a rising foam. So we're feeding from the bottom, boiling up through the heat exchanger here. The oil and vapor mixture splatter against here and it sort of gets all over the place so you can't really see into it. But the liquid flows down here. There's a slight slope to this down to the oil outlet discharge. And then of course the vapors come off the top to the condensing section. And we find that the rising film is at least as effective as the falling film. I think it actually has better distribution because gravity distributes the film for you and you don't have to have distribution plates or worry about overloading the column. And I think you've noticed I haven't actually touched any controls on the system. Everything is fully automated. Like these are all the parameters for like manual control, but honestly, it's impossible for a person to do it. The computer's doing all the optimization and this is the only screen that you really have to interact with. And it shows the rates, the residual solvent, start, stop, and allows you to change the residual solvent target. Oh, yes. So if this starts pulling air, one, it's actually pretty tolerant to that. Like I can just pull it out and it won't stop the system by itself. But if I leave it pulling air for more than a minute or two, it'll start throwing off enough of the system and it'll notice that it's not processing as much material and it'll do an auto shut off. So you can just run this lights out and it'll just automatically stop. And there is an option if you get tanks from us or add tanks with a level switch, you can even have it automatically turn on when your feed tank starts getting full. And right now we're running an ethanol crude, but the system can be used for any liquid hydrocarbon. So pentane, hexane, heptane, all of those, even like acetone or water, can be distilled on this as well. So all of this is like these are pharma grade heat exchangers. So they're tube and shell. There's lots of little tubes. There's very little hold up in the machine. When you drain it, there's only a few grams of material left. If you flush it with ethanol, that should clean it out really well. And that would be a CIP. Honestly, even that's debatably necessary depending on your SOP. And then maybe every blue moon, you might want to disassemble it and inspect and clean it. But again, it's all tri-clamps, very easy to disassemble. These stay in place. But yeah, you unbolt the separator and then you can access all of the tubes to clean it. But most of the time, you're just going to do a little ethanol rinse and call it good. There's no real consumable parts. Everything's warranted. Like you have gaskets and stuff, but again, you're not servicing those gaskets on any regular basis. So all the gear pumps are super hard wearing. There's no need to service those. There's no seals to replace. At least for the first year plus. Valve is automatic. Yeah, just a rinse every once in a while will do you. And to reiterate, like this is a true distillation system. So it's not a membrane recovery system where the membranes get like used and consumed. This is like pure. The only thing touching the material is stainless steel. So nothing wears out and it stays really pure. But because of the heat pump, it's almost as energy efficient as a membrane system. This uses about 1/4 the energy of a comparable falling film and even less compared to a rotovap. This whole system's running on one single phase 30 amp circuit. That's it. That's the whole plug. Drawing less than 30 amps, which is less than most rotovaps. And it's doing the output of like 5 or 6 rotovaps. Thanks to everyone who's joined. If you have any questions, just let us know. This is like a super automated machine. There's only start and stop buttons. So any questions you have, that's what I'm here to help. Okay. The question was, will the system auto adjust to account for minus 20 Celsius feed material? Right now we're running room temperature, and it will auto adjust. It just will auto adjust to run a little bit slower so that it hits the same residual solvent target in the oil. So you get the same oil quality coming out. That's what this machine is tuned for. And again, that setting is programmable. Right now we have it set to 5%, which is a pretty thick crude. You can see it coming out. It's like doing the coil thing, coming out pretty slow. But a lot of people run 10 or 15% just so it's easier to pour. What is the percentage of residual terpenes in the recovered ethanol? Ooh, that's a good question. I don't know that. I think that depends on your material and if you have any lightweight terpenes. I do know that the ethanol quality is extremely good. There's no coloration of the ethanol at all. We've done other tests where we reduced various impurities in this is wastewater by like 99.9%. So unless there's a very volatile terpene, it's not getting into the ethanol. And then again, the residual ethanol in the oil, that's a program setting. So you can set that to whatever you want, 5 or 6 or 10 or whatever percent you like. Drying agent and ethanol in the vapor phase. Ooh. I think that would be really easy to incorporate a drying agent. Like this is a stock UBED part. We could put drying agents right there if you like. You can also just repass your ethanol and get it up to 95%, up to azeotrope by distilling out the water as the residual. That would be a dedicated pass, but it can be done. So it can already do liquid hydrocarbon. So all your pentane, heptane, hexane, even octane probably, it can do all those. We just need to get it rated for pressure rated for butane. And by the way, it's this hydrocarbons that usually about 90 liters an hour or like 70 kilograms an hour. So that's like 150 pounds of butane per hour.